In this video, we're going to discuss inverse tangent. If you have not yet watched inverse sine and inverse cosine, please watch those first. Just like sine and cosine with tangent, the tangent function is not one-to-one. So in order to make the inverse be a function, we need to restrict the domain of the original function. So what we're looking for is an area of this function where we have all unique y values. And that area is going to be between negative pi over 2 and pi over 2. So that's the same as what it was for sine. If you look at the tangent function from negative pi over 2 to pi over 2, you have all unique y values over that domain. If you go beyond that, then we start to repeat y values. Okay, so we're just going to look negative pi over 2 to pi over 2. All right, so with the tangent function, the domain's a little bit tricky here. The domain is all real numbers except x cannot equal every place that I have a vertical asymptote is somewhere that x cannot equal. So that first vertical asymptote is pi over 2. And then if I add any multiple of pi to that, I'm going to get another vertical asymptote. So pi over 2 plus pi would give me 3 pi over 2, plus pi would give me 5 pi over 2, and so forth. And those are going to be the places where we have vertical asymptotes. So that's our domain. And then our range is infinity. It's all real numbers, right? So, you know, my graph would continue to go down forever and up forever. It would just get closer and closer and closer to those lines, to those asymptotes at pi over 2 and negative pi over 2. But your y values will continue to get larger. Now, because my range is infinity, or all real numbers, our domain here is going to be all real numbers. Which means I can plug anything I want to into inverse tangent. That's different than sine and cosine. With sine and cosine, that had to be a value between negative 1 and 1 that we were plugging into inverse sine and cosine. But with inverse tangent, I can plug in anything I want to. But the value that we're going to get from that is going to be different. Okay? And that's because we had to restrict our domain here from negative pi over 2 to pi over 2. So our range of values are going to be negative pi over 2 to pi over 2. Okay, all the values that we get in our tangent function, or our inverse tangent function, are going to be negative pi over 2 to pi over 2. And again, that's the same as sine. So when looking at tangent, thinking about the right side of the unit circle, we are going to get our values from negative pi over 2 to pi over 2. So, arctangent of negative 1. Okay, so what we're going to do is go to our trig sheet. We're going to look at tangent. We are going to look for when it is negative 1. Now, again, that's the first value I got here is 3 pi over 4. That's not in our range of values from negative pi over 2 to pi over 2. Okay, that's in quadrant 2. We can't use that. So, the one that we want is this 7 pi over 4. But again, we don't want to use our quadrant 4 angles. We want to just say negative what it is in quadrant 1. So my recommendation for both sine and tangent is to just look at quadrant 1 and ignore the negative. And then if there is a negative value, just make the angle negative. So I'm going to look for not when tangent is 1 or negative 1. I'm going to look for when tangent is 1, just in quadrant 1. And then I'm going to say, okay, that's at pi over 4, so I'm going to make that negative. So this happens at negative pi over 4, which is down here. Okay, we're going to call this negative pi over 4. Inverse tangent of root 3. So again, just look at your sheet here. Look for when tangent is the square root of 3, and that happens at pi over 3. Just again, looking in quadrant 1. And then arctan of negative 20. So negative 20, clearly not a unit circle value. I'm going to just use my calculator for this. I'm going to do inverse tangent of negative 20, and I got a value of negative 1.5. Negative 1.5. And again, that value that I get should be in that range of negative pi over 2 to pi over 2, and negative 1.5 is in that range. Okay, so just like sine, we're looking negative pi over 2 to pi over 2 for those values. Unlike sine and cosine, I can plug in anything I want to into my inverse tangent function, and I will get a value.